Hey, I'm here. I'm ready to start. It's 7:55, we'll give it a few minutes, probably till 8:05, and then we can start. Okay, so I think we can start about now since I don't think anybody is joining anytime soon. But if anybody does, I'll just repeat it again, so no worries about that. So first, I'll just introduce myself. I'm Keshava. I took this course last winter, and currently I'm on AMAX, just serving as the academic rep for A48. So first off, I wanted to say thank you all for being here. I hope this helps you for your upcoming midterm. I know the A48 midterm can be tough sometimes. I didn't particularly do well on it either, but I managed to do much better on the final, so I hope this helps you out. Second of all, this meeting is being recorded because I just want to have it available just in case any of you want to reference back to it, or if somebody who wasn't able to join because of time zone or some other restrictions, they can join. Uh, they can watch it later. So first off, can everybody hear me? Okay, by the way, is can thumbs up? Okay, perfect, cool. So first off, what I plan to do today is I will have I'm gonna review a past midterm that I have on Crowdmark, just because it's not mine, but it's very similar to mine. I just don't want to go over mine because for privacy concerns. But this person gave consent and everything, so it's cool. But yeah, this midterm should be somewhat similar to what you expect. I know I do understand it's happening on Proctor U, or no, it's not actually, right? It's not happening on Proctor U, so this should be actually kind of similar to what you might be receiving for your midterm test. And yeah, so uh, after that, after we go over that, that shouldn't take too long. I'll open the floor for questions, and you can also ask questions in between. And if you guys still want another review seminar or want to ask more questions, I'll also have a session tomorrow where we can talk some more or go over some more topics. Does that sound okay? Perfect. So I'll just share my screen. Duh, duh, duh. Yeah. Okay, cool. So I'm guessing you guys can all see my screen. What I'm going to do is just check something here. So what I will ask, just because when I share my screen, I can't really see the chat. So if you guys can unmute and speak out if you have a question, that'd be great. Just because I can't quite see. So yeah, I'll just go over this. This person did quite well, so I'll use it as a good example. So basically, first I'll just go over the basic structure. So you have like these short answer questions where it's like fill in the blank or like write a few lines of code. You will definitely be asked to do something related to the memory module. It's practically guaranteed. You will be asked something like this, typing out structures in C, which you should be familiar with. Some basic like mutating that structure, whether it be changing a name, adding a number, or adding two numbers, or removing or adding a string, something like that. You will definitely be asked that. String functions, so using the various string functions that you learned, like strcopy or strcat, using functions, you'll probably get an easy bonus mark like this. Um, you will also be related to ask questions related to pointers. Definitely, 100% linked list. You will get something related to linked list, whether it be it'll probably be you'll probably be asked to implement a function, whether it be search or insert or something like that. You'll definitely be asked one of these I can't talk today. Explanation questions like this, something related to the memory module again, and then multiple choice. And I will say sometimes they typically use multiple, like they reuse it or they ask very similar questions. Sometimes multiple choice is quite tricky, so we'll make sure to look for that. So I'm just gonna quickly stop sharing my screen just so I can check the chat. Okay, perfect. I'll just share that again. Okay, perfect. So, and I'm recording. Perfect. So I'll go over the first question. It's fairly simple. So we have to read the following piece of code and complete the required variable declarations in the gray box on top of main. Blah, blah, blah. Make reasonable assumptions where needed. So we have to fill in the blanks with variable declarations, nothing more, nothing less. So that's our kind of our key. So what we should first do is look at the other code. So we have a variable called x, we have a variable called y, we have a string called a, clearly, because you can kind of see how it's an array, and we use the end of string delimiter here, so we know it's a string or a character array. And the thing that really gives us the hint here is the printf statement, because it's percentage %f, percentage %d, and percentage %s. Percentage %f meaning float, which is y, so we know y is a float, so we can write that down. Percentage %d meaning integer, so we know x is an integer, so we can use int x. Then finally percentage %s, which we know is string or character array, so we can do that here. You shouldn't just declare like an empty character, like you shouldn't just leave it as char a open bracket s close bracket semicolon. You should you should have initialized it with something, just because here they're just going straight to those indices and changing them directly. You're not using like an str function, so you do need to initialize the array with something. That way you can actually reference these characters without getting any errors. So like this way, this person just referenced it with something random. It could be totally anything you want. Just make sure it's 6 elements long plus this end of line delimiter. Okay, next. So now we have to fill in the blanks with the appropriate, I guess, keywords. So obviously here is the return type. Here are the types of the parameters. These are just variable declarations, and then this is just the main function calling it. So we'll go step by step. So first, I would advise you to mainly look at the main function just because that's what's calling this function. So we have a float x, which is equal to 4.0. Int trials is equal to 10. So I already know x is a float, trials is an integer. And then we printf something, and then we call that function. So what really gives us a hint is we know x is a float, but we also know that this function should return a float when we check this printf statement. So we can already assign a type float to the return type of this function. Next, we know that this function is taking it on x and trial. So we know x is an integer. X is a float. So we can already declare type float. Similarly, trials is type integer. So we give it a type int here. Next, we also have to look at the variables here. So we know if you look at xn, it's equal to s, which is here. We know s is a float, so xn has to be a float because you can't just declare different type of number variable types and expect it to work. So we will initialize xn as float. Next, we're using I. It's pretty simple. We're using it in a for loop, so we typically use integers in for loops. It wouldn't really matter if you made it a float or double, but by protocol and standard declaration, we'll use an integer. And then we just fill in int I, and we get those easy points, right? So it's pretty easy, these questions. Okay, similarly, we need to return the average of 3 quizzes. I'm going to go by a little quickly just because some of these questions are basic and I want to get into the more complex questions. So I'm just going to, just stop me if I'm going a bit too fast, but we get 3 floats representing 3 scores. So we do Q1 plus Q2 plus Q3, and then we add those all up. What I will say is I would tend to be careful just because you're getting a pointer. And I think they missed this in marking, or I'm not sure if this is correct, but I would put the star or around, like I'd put the brackets around just to make sure that they know that you're referencing the value, not the pointer address. And then we divide by float 3. This is very important because 3 is a type of integer. So you can't do operations with like competitive variable types. They all need to be the same, or else like C will automatically typecast them, or sometimes you'll get an error. It really depends. So in this case, make it float 3 because obviously you don't want your average being rounded up by an integer. You want it decimal. So we typecast 3. And then we just call that function and we pass in the addresses of those quiz marks. So at quizzes at index 0, at index 1, and at index 2, we use the ampersand symbol to specify that we're passing in the pointer to that location, not the actual value itself. So right below, variables for main go above this line. So these are the variables regarding this, regarding the main function. So quizzes 3, they obviously have, they're all float types. That's very easy. I would say you should put a box around your array just to specify, because right now it just looks like this is a part of it, and then these 2 are just empty. Obviously the the marker was lenient, but I would put a box just to make it organized and make it clear. Average mark is 0. Yeah, that's correct because that's how you initialized it. The return value is wrong. Yeah, so that should be 0 by default in the main function, I believe, because even if you don't put that return 0 in the main function, it will automatically give you a return type of 0 in the main function. I do know that. So that should be a 0. So that's like one of those sneaky edge cases that kind of sneak up on you. So just make sure that you note that. And then this is the variables for the actual quiz average function. So likewise, we have the pointers to those variables. So as you can see, quizzes was stored in memory addresses 3241 to 3243. So when we pass it in, the pointer address for the first quiz mark is 3241, referencing this one, likewise to each box. And then the return type for quiz average, let's just check here. So it is a float. And I think this person just kind of missed. You should have probably calculated the quiz average quiz like the actual average itself, you shouldn't have left it empty since the function was called. But yeah, other than that, pretty simple. And let me just check my chat here. Okay, perfect. Yeah, nothing going too wrong. Sorry about that. Just making sure. Next. So this is something you will 100% be asked, which is declaring a structure in C, a compound data type or structure, however you want to call it. So let's go over this. So basically they want you to, they want you to declare a structure to hold the information about knockoff Pokemons, which are Pikimons. So they have the following attributes, which is a name, which should be cool sounding, okay, age in years, hunger from 0 to 100, picture, a char array, looks like of size 256 by 256, voice, a floating point array of size 88,200 by 2, containing 2-second digital recording of its voice, that's fine. So for the chart name, this person used 1024. This is something I like just because in your assignments or whatever, whenever you like practice or get exercises, you typically do see 1024 declared as a macro. Like you'll see max string len def max string len 1024. So just use 1024. And it says it should be cool sounding, so that might imply it might be long. So this is always a safe bet. Age, it's in years. It can live up to 1,000 years. So int is perfectly fine for that. Hunger, it specifically says from 0 to 100. So that's obviously an integer. It gives you what the picture and voice types should be, a char array, simple as that, which we're given, and then a float array of 88,200 by 2, which we're also given. You just declare. Very simple. All right, you should be able to nail this because there's no reason not to. Now, in the space below, provide the definition of the data. Oh, I think I got a chat message. Yeah. Yes. So the recording, yes. So I'm once it's done recording, hopefully it gets downloaded on my computer without a hitch, and then I'll post it either on YouTube or some other site, and Brian will make a post in Piazza with the link later on, hopefully today. I don't know, since this recording might be long, I don't know how long it'll take to download or render or things like that, but I'll try my best. But hopefully by tomorrow morning, tomorrow noon, I say tomorrow by 12 p.m. like lunchtime, it should be up somewhere. Yeah. Does that answer your question? Okay, perfect. Uh, so next, having traveled in the space below, provide the definition of the data types needed to support one node of the linked list. It must contain the data for one Pokemon plus an array with the coordinates, and then obviously since it's a linked list, you need a next pointer. This is very simple. We use Pokemon creature because we need to store a Pokemon itself. So we declare one as a creature right here. We use an int array for the coordinates, but as you see, this was wrong. Apparently it needed to be a float. It really doesn't say anywhere that it needs to be a float. And plus in like, yeah, this one, it's kind of a dumb mistake, but you know, better to make, if you see ever see, maybe you guys will get the same question, maybe use float instead of int, or ask Brian if you can. Finally, we use struct peak node star next because that's our next pointer to this structure itself. Since this is a node and you're declaring a pointer of its own type in the structure itself, you have to use struct peaky node star next, right? You can't just do Pokemon node star next. That wouldn't work. So that's also very simple. So these two questions you will like 100% get something related to declaring a structure, and then something related to like a linked list, like creating a node or something. You'll like definitely get that. This question looks pretty long, but it's pretty simple actually. So basically, as noted before, we have 2-second recording stored within an array of size 88,200 by 2 called voice, meaning that there are 88,200 digital sound samples and 2 channels left and right. That's why they did it by 2. That's why it's so like the first array is the left is the left side, the right channel is the second element in the array. So there are floating values. The left, so yeah, left channel. So at position 451, if you wanted the left channel, that would be stored at 451 at index 0. Right channel is stored at index 451 1. So these are floating point values in -1 to +1. If you send this blah blah blah, you can send it to a sound card. So you have determined the samples to be fixed, which means set to 0 by hand, are at indexes these values, right? I'm not going to read them out. So you need to reset them. So how do we do that? So you could technically, I guess, so you get this, Pokemon creature. So you do need to fix them. You could just do Achu pick. What kind of Pokemon is that? Achu pick dot voice, and then this one at 0 is equal to 0, things like that. That's pretty long though. That will take you 6 lines of code, and it might not look great, and you probably might get some mark stalks just because you should know a better way to do it. The simple way to do it: create an integer array of 3 elements, put these in, then run a loop for 3 times, where you go over each channel left and right and just set them to 0 at these values. Very simple. So are we all good so far? Could somebody message in the chat and tell me if we're okay? Is everybody good? Is everybody okay? Could somebody message? Perfect. Okay, great. So, all right, I'm just gonna keep going. So, next, while solving the issue, you realize it might have been a little useful to have a little function that could modify the name of a Pokemon. Right, so you're given a name, you're given a pointer to a Pokemon creature, and then a name, and you want to update. Oh, I got something. The previous question. Yeah, sure. So, so this is what our Pokemon structure looks like. Are you clear with that? If I can ask you that, are you good with that? Okay. So, I'll just put this over here. So, our Pokemon structure has an array, or 2-dimensional array, called voice. It's 88,200 by 2 elements. Do you understand how that would work, right? Could you let me know in the chat, like that this right? Okay, perfect. So it's saying that the left channel is stored at, well, let's say at position 451. The left channel sound, I guess, information is stored at voice at index 451 at index 0. The right channel is stored at voice 451 at index 0. Do you get that? Okay, so it's giving us certain samples to be fixed. So it says, okay, so at these indexes, the voice channels need to be set to 0. Do you get that? It's just asking you to do it. There's like no reason why. It's just you have determined the samples to be fixed. It's just something, yeah, Brian's giving you, or Paco's giving you. So the way this person did it. So I'll give you an example, right? So I'll just type it in the chat, 23581, right? So actually, hold up. I can just pull up like a notepad or something, because this is pretty simple. So here you see how they've given us a Pokemon called Achupik. Are you clear there? They've given us a Pokemon called Achupik. Yeah. So I could do it like this. If I wanted to reset these at the sound at these positions for both the left and right channel, I could do something like this. Yeah. So I could do Achupik dot voice. Oh, perfect. I got the limit back. Nice. I could do something like this. 23581 colon bracket 0 is equal to 0. and I could just take this and copy paste it and this like this. Do you understand why I'm doing this? Because it's the question's just telling me to set it to 0. Are you with me so far? Okay, so basically, this is a lot of work because there are 3 numbers. It's kind of tedious. So what this person did is just created an integer array with these values. So 2, 3, 5, 8, 1 is the first element. This is the second element. Third element is the third element, right? All they're doing is looping over this array and putting in these elements and then modifying both the left and right. Yeah, exactly. So it's, yeah. So not too difficult, but it's just kind of an elegant way of doing it. Plus, if he gave you like 50,000 things you needed to fix, it would be the same process. So yeah. Okay, perfect. So we're good there. Good question. Yeah. Sorry, because sometimes I'm not too great at explaining things perfectly. So basically, I went over this one. I believe that you just have to use the strcopy function. I will say this though, be very careful about this. They're giving you a pointer, not the pointer to the object, not the actual object itself. So you have to use arrow notation, not like a dot or something. When you're accessing fields within the structure, you have to use an arrow. So be careful about that. And then here they're just calling the function, but notice how they're using the @ symbol. They have the actual structure itself. It's not a pointer, but since this when we mutate, I guess, sorry, mutate's not a good, when we change fields within a structure using functions and things like that, we pass it through as pointers. We don't pass the actual object itself, just because for memory reasons and for practical reasons that it's not good. So we use pointers instead because it's much more cleaner. So we're passing in the pointer using the ampersand symbol and passing in a string. So that's why in the function notation or declaration, you see a star here to like tell you it's a pointer. Here, this is a very difficult question, extremely difficult. People like struggle with it all the time. Just try your best. I don't know if you'll be able to get it correct. Moving on. Every now and then, Pokemons get adopted and taken off the reservation. Blah blah blah. Complete in the space below the code for delete PK function that removes a creature node from the linked list. Okay, so this is something that's pretty big. So right now they're asking you to simply implement basically a delete function for a linked list. That's basically what it is, right? So here they're giving you the head of the linked list and they're giving you the node of the Pokemon node to delete. And also I must add, they're asking you to delete the creature matching the name provided. So that's the name of this node that they've given you. So basically, this is pretty simple. So we have to get the head again, just because that's what we're using. And then we're also using Q. I'll explain that why later. So before the loop below, if P is equal to delete, so this is basically saying if the root is equal to the node to delete and P doesn't equal null, so making sure that the head actually exists, Q equals P dash next, and then we're freeing the P node and then we're returning Q. So that's why we created a Q thing here, is to get the new head, just because if we free P or the head, then we can't really return back the head since we've just freed it, if you know what I mean. So that's why we use another pointer variable. So while P does not equal null, if P equals delete, Q dash next is equal to P dash, so if P is equal to delete, so if P is actually equal to the thing we want to delete, we do this, else Q is equal to P is equal to P dash next. So if P is equal to the node to be deleted, Q dash next is equal to P dash next. So Q is now being equal to P dash next, free P, and then we return head. Simple as that. And then if something always needs to be returned, so we return head always. So let's say they give us some bogus value for the node and we searched out throughout the list and we couldn't find it. If we kept this code, nothing would be returned, which isn't good. So we always have to return something at the end, which will be head, because if nothing's returned, we can just return the basic head itself. So yeah, this is like a question you should be careful on, because like there's a lot of like places you might like not consider. So in this case, this person remembered to consider that, oh, if the head is the, you know, problem or like the thing to be deleted, we might need some special cases for that. So something like that. So just be sure you remember that. Let me just check here below. Q doors next is go to P. P, turn head. Yep, that makes sense. Yep, okay. So, next question. Oh, okay. So this is crunchy. This is something Paco says. It's feeding time for the Pokemons. We need to know which of them are super hungry so you can feed those first. This will help avoid the situation, blah, blah, blah. You decide to write a function that will return a list of the Pokemons whose hunger level is greater than a given threshold. However, you do not want to duplicate Pokemon data at all. This means you should not make copies of the Pokemon variables or Pokemon nodes. In no more than 5 steps, describe the process you will use to implement this time. So let's go over this person's solution just to make sure they kind of align with mine. So what they mean by given threshold is, so if you recall, the Pokemon's hunger level can be anywhere between 0 and 100. So yeah, so when they mean by a given threshold, they might be like, all right, dude, we need to really feed the Pokemon's hunger if they're above 80. So they'll give you 80. So this person's solution is traverse through the list and count the number of Pokemon whose hunger levels are greater than the highest threshold. So basically, this is a simple while loop, looping through all the Pokemons, and then just doing something like if p.hunger is greater than or equal to threshold, then count plus equals 1. So this is just getting a count. Dynamically allocate memory to a Piki node pointer array of the size above. Yes, this is very good. Using calloc, yeah, that's you could say that, you couldn't, but this is good. Add to the array the addresses of Pokemon nodes with Pokemon more hungry than the threshold, then return the pointer to the new array. So what I'll kind of just make this solution kind of like just put it into better words, just because I've kind of just blindly read through it. Basically, first you need to go through all the Pokemons just to see how many of them are hungry. The reason why is because you need somewhere to store all those pointers to the Pokemons that are hungry. So we count all of them first. Let's say there are 5 Pokemons in total. We find out that 3 of them are hungry. Then we create a Pokemon pointer array, not a Pokemon array, a Pokemon pointer array, and store those pointers in the array. Simply like that. So we go through so we've done one loop of the Pokemon list, we'll go through another one just so we can actually collect those pointers, and then we just simply return the pointer to the array itself. That's it. So yeah, draw a diagram that illustrates how the list by your function works. So let's see, this person's written. Oh, okay, so this is what they've done. So they have 20 Pokemon starting from 1 to 20. And then the return, so now out of all of these, some of them are hungry. So yeah, so some of these are hungry. So we just return back the pointers of those. So let's say, so in this one, locker numbers 41, 42, 43, 44 were hungry. So we just return those arrays back. We just oh, sorry. 41, 42, 43, 44 are just numbers. Here, 2, 5, so Pokemons 2, 5, 11, and 19 were hungry. So 2 is here, 5 is somewhere here, 11 is here, 19 is like right before, and we figured out, oh, these 4 are really hungry. So we just put them in an array, and then we return. When you return an array, you're actually returning the pointer to the first element in the array. So that's what they're doing. So you would just return this pointer, a pointer to this value here. But that's basically it. So now we're just going to go over some multiple choice. So we're almost done. Some of these are actually pretty tricky. So the best thing to do, I find, is use process of elimination, just because that like helps you, make sure you're correct. So which of the following is not true according to the memory model we've been using for programming in C? So each variable has its own box. We definitely know that's true. We've like seen that before. We've literally done a question earlier where each variable has its own question. Parameters get their own box. That's also true because in function declarations, each function parameter or argument gets their own box. We know that's true. Boxes in memory have different sizes. This one you might like struggle with just because you're used to drawing boxes all the same, but that is true just because, like, for example, integers are smaller than like floats or doubles, so you should like think about that. And then the locker number where data is stored doesn't matter. That's true because who cares, right? If my array is stored from 1 to 10 or it's stored from 1 million to 1,000,010, does anybody really care about that information? No. As long as we have the addresses, that's all that matters. So that's definitely true. Last but not least, a box can have more than one tag. Does that really make sense? That doesn't make sense because if I have, let's say I want to store my name and my integer, can I store them in the same box? No, that it doesn't work like that, right? So you can't. So this is definitely false. So it's not true. So C is the answer. We use explicit typecasting because the compiler doesn't do typecasting automatically. That's somewhat false. I do know some scenarios where it doesn't, but most of the time it does, or it'll throw like a weird error or something. But yeah, I might get stuck on this one. Without our code, it won't compile. No, C will like compile because it won't check for everything, so it will compile. It might not work, but it'll compile. It saves computations. That doesn't make sense at all because compilation really doesn't count as like a computation. Variables have fixed data types. I don't even know what this means because a variable is of a data type. So variables have a fixed data type. This statement doesn't really make sense. It helps avoid bugs. This is true. So what I mean by bugs is, let's say in a good example is if do you guys recall the quiz average question we did above? Could somebody tell me in the chat, or did like the quiz average function above? Could somebody tell me if they recall that? Or should I scroll up to it? Okay, I'll just scroll up to it. No harm. So let's see here. Oh, there. Here. So we're returning the average of 3 quiz marks. So we're adding them up and then dividing by 3. If we didn't have this float here, it might work, but it might round to an integer, which isn't what we want. So that could be qualified as a bug. Or it might not work at all, but it will still compile. So that's also a bug. So we have to typecast float so we know we don't get any errors or we don't get any incorrect output. Plus, it kind of helps us show if it shows the programmer knows what they're doing. So for future reference, let's say I have to somebody else gave me this code and I have to implement more functions on top of that. So I was just like, oh, I got to add, add a add mark function. I got to do a delete mark function. I got to do the return mode function, return mean function, return median function, things like that. If I can see this code, I'm like, oh, this person returns it in the type of float, and they've like made sure to like actually show it. So okay, so I know how to do that. So it's kind of like more evidence to more structured, better nomenclature, things like that. Okay, so we're okay there. Then one of the following options must be true after we execute the code y equals char x. So x will be of type char. That's horribly incorrect because you're not actually doing anything to the value of x. So that's definitely not true. Y will be of type char. That's also not true. Just because you typecast something, when you assign it to a variable, it doesn't mean the variable will automatically become of that type. So if y wasn't initialized of type char, then it's not going to magically become type char just because you typecast a value to it of char type. So that's not true. Y and x must have the same value. That's not true at all either, because if x is an integer and you typecast char for an integer and assign that to y, y and x will definitely not have the right value. y will have a value equivalent to the char value of x. That makes sense because that's what literally a typecast is. You are giving y a value equivalent to the char value of x. I'll give you another example. Let's say you have a variable called uh, x, which is equal to 2.5, and then you have a variable called y, which is just equal to, uh, like it's just an integer, y. If you do y equals, you know, int x, x is a float. So how would y and x have the same value? X is equal to 2.5. You don't know what you're going to get with y, but you're not going to get 2.5 because it's an integer. You'll get an integer. So that can't be true. Y will have a value equivalent to the char value of x, or integer value of x in my example. That's definitely true. So this is the correct answer. Uh, this one. This is actually a tricky question. I'll be very, very honest with you. If I got this question, I wouldn't know which one's the correct answer. Because, I wouldn't, typically know how to approach this type of question. So I'll just read it out. Give me a second. I'm just going to grab some water. Give me 1 second. Okay, I see some questions, so I'll just go over that. So char value, so are you referring to, I see your question too, Mahek. So I'll get to that too, but I'll answer Zexi Sun's question first. So are you referring to this right here? These open and close. So this is something called a typecast. So we typically use it when we're working with different variable types. So something common I see is sometimes you want to typecast a float to an integer. So I'll give you an example. Sometimes y is equal to, let's say we have a variable. I'll use different variable names since I don't want to confuse you. Let's say we have a variable called a. Okay, are you with me so far? We have variables a and b. A is a float, and we give it the value 3.0. Okay, a is equal to 3.0. B is an integer, and it's equal to, we want it to be equal to 6. So we do a times 2. The problem with that is sometimes we might accidentally assign it equal to 3.0 times 2, which is 6.0. It's not 6, or the opposite way around. So sometimes like that, it might either cause like a bug in the system if you try to, like assign a different variable type to a different variable type. So in this case, a float to an integer. So we do typecast to tell the compiler, hey, I know these two are different variable types. Can you make it one variable type, just to, make sure the code compiles, no bugs, things like that. Sometimes it might work, sometimes it might not work. I'm not like, I'll be very honest with you, I'm not too familiar on the situations where it would or would not work, but that's just kind of the reason. We use it to let the compiler know that we want to switch over from one variable type to another. Are you good with that? I assume that one. Well, you're not given that at all, right? Yeah, like nobody gives you that. But y is of type char. Uh, the thing is about C is you can do whatever the hell you want. The thing is, so y might not be of type char, but you could still give it that value. It's really weird, but it's actually possible. Y would be complete. It would be equal to complete garbage though. Like you couldn't parse it after that. Like you couldn't do anything with that value, but it will work. But there's no way of without it telling, like the question telling you if it's of type char, you can't just assume that. Are we good? Okay, perfect. Sorry, why wouldn't, so Mahek, why wouldn't 3C be correct too? Must be true. Okay, so this is kind of the question I just addressed. Mahek, are you still with me? Were you listening? Yeah, okay. Yeah, okay. But I'll just go over it again. Just because you typecast something to a value, it won't be automatically be equal to of type char. It will. It seems like I get what you mean, and to be honest, if I was doing this exam, I might have like circled it, being like, yeah, why has to be of type char, but just because see, Paco tells us, I understand your professor is Brian, but like when I had Paco for this course, and basically he's like, well, the bad thing about C is it's kind of complex. Not that it's complex, but you kind of have to do everything for it. There aren't these like nifty libraries or functions that'll do things for you. Uh, but the good thing about C is that it's freedom because you can do literally whatever you wanted as long as it's the syntax is correct and it's not nothing too crazy. You can do whatever you want. So if y was of type int, I'm almost sure that you could figure out a way to typecast a value of char x and put it into an integer array. Or integer type variable. It sounds stupid, but you could do it theoretically, right? So that's kind of the reason why you can't assume y can be of type char, because it's possible it won't be. Are we good there? Okay, perfect. So the reason we have different numeric types, so this one's actually kind of tricky too. The reason why we have different numeric types for integers and for floating point numbers is, so this person is the float variable requires more memory because they have more digits. I'm pretty sure this is true, but the reason you have different numeric types for integer and floating point isn't because float variables require more memory, and it's not because it's a quirk of the C language, because C is not quirky for the sake of being like weird and quirky. It's quirky for a reason. It's a convention that programmers use to make code more structured and easier to debug. That's not true either. And notice in this, out of these options, you don't actually see something saying, oh, integers for whole numbers, floating point, you can store decimals in it. So that's not an option. So the actual answer is the CPU has separate circuits for these numeric types. I didn't believe it either. I thought this person was correct when I was going through this midterm the first time, but it's actually 4A. CPU has separate circuits for these numeric types. And once I thought about it, it actually makes sense. And I'll offer you a reason on top of that, just so it kind of reinforces your idea and you learn it better. C is what, you've probably heard this before, but I'll say it again. C is a low-level programming language. It's probably one of the first programming languages other than assembly, right? So it's very low level. It's very low and close to the hardware level of a computer. Python is like fairly high level. It goes through all these parsers, all these certain things to make sure it's compatible. C is right at the bottom. So you have to make sure it's already compatible. So looks like the CPU has separate circuits. I didn't know that, but it has separate circuits for these numeric types. So it makes sense why integer and floating point numbers would be different, and you couldn't just make them the same because the circuits are different for these numeric types. So they have to be distinct variable types as well. But yeah, that one's definitely kind of tricky. So which of the following options is not a potential result of changing data outside the bounds of an array? Your program crashes. That could happen. Yeah, that could happen. That actually can happen a lot. I don't know if you guys have done this, so please correct me if I'm wrong. But basically, I'll tell you about something. Are you guys aware of how you guys know that string arrays have end-of-line string delimiters? Are we all good there? Can somebody tell me in the chat? They know that, right? Perfect. So end of line, so let's say I have a string called cat, right? So we have the characters C, A, T, and then end of line delimiter, right? So four elements, three characters plus the delimiter. Are we good there? Do we understand that? Could somebody tell me in the chat just to make sure? Okay, perfect. The funny thing is, if I were to go in and change that end of line string delimiter to some other letter or some other character that's not the end of line string delimiter, and then I said print my, let's say this is assigned to a variable called, let's say, my pet, and I said, okay, C, printf my cat, and it's of type string, C will keep going and read everything. It will literally be pure garbage after the first three letters. It'll be cat, and then BF, numbers, colon, it'll just keep reading it until it accesses something that it shouldn't and crash. And Paco actually did this in class. He was able to read like 10,000 or like 50,000 characters that were just residing in the memory. It's pure garbage, but you can do it. But then your program will eventually clash. But I will say this, when you try to change data outside the bounds of an array, you will probably get a crash most of the time. But to read it, you won't. You might not actually. You'll be able to go for a decent while, but changing data, then you will definitely get a crash. So that's just a little fun anecdote, and it might, who knows, it might help you out. But yeah, your program crashes, that could definitely happen. The program runs but produces a weird output. Oh yeah, this is kind of what I was talking about. Changing data. This could also happen. B. Oh, it looks like 2 option number B's. Okay, it looks like that's a typo. The value of other data in your program may change. This could be somewhat true, just because take for example, when you have structures in C, you have names, you could put names, integers, things like that inside that structure. If you were to change one memory module outside the bounds of your array, who knows, you might be changing a memory address box of a particular structure. So that could potentially change all the data in that structure. You know, you might be changing a name, you might be changing an array or string, things like that. So that's definitely possible. See, nothing happens. No, that the compiler throws out an error when your code is running. So, which is not a potential from changing data outside the bounds. So actually, yeah, so this is actually very true. The compiler cannot check if you're doing things that are illegal. When you're trying to compile your program, you won't get an error because syntax-wise, you've done nothing wrong. So it's impossible for the compiler to throw an error at you, right? So yeah, this is the obvious, like the compiler won't catch like your mistakes like that. Like it'll most of the time like catch certain things, but it won't catch like syntax mistakes or sorry, it will catch syntax mistakes, but it won't catch you doing like performing illegal actions. It just won't. In your tutorials, your TAs, and let me just check something real quick just to make sure. I know some of these were wrong. Yeah, 4, yeah, which I checked, 9, and then 15. Okay, cool. Your TA, blah, blah, blah. What does it mean out of, yeah, good question. Sorry if I didn't explain that. So let's say I have an integer array and I declared it of type, of size 4. And let's say I call it my array, right? Yeah, string 4, if you try to access, yeah, 5 and later. Exactly, perfect. Are we good there? Perfect. In your tutorial, your TA showed you how to allocate an array of a particular size using calloc. Suppose you use this to allocate space for a new string with the capacity of 1024 and get pointer p to your new array. You then store the string of your of the text I can't talk today. You then store into that string the text help. What is the value of pointer plus the p plus 4? This is a good question because a lot of people might get confused. So let's just look. So the thing is, at p, at like the pointer p itself, this is your what's being stored there, the letter H. At p plus 1, it's E. P plus 2, it is L. P plus 3, it's P. And then P plus 4, end of line string. So sometimes somebody might see like plus 4 and be like, oh, it's plus 4, you know, P, that's the 4th character. No, it's you actually have to, it's actually kind of like one more almost. So you have to also consider P plus 0 itself almost. Like this is, you could also technically think of this as P plus 0 if you really want to think about it like that. This could help you. So my best thing is probably like write it out if you want to be certain, because this is like a really dumb question to like make mistakes on. Like you want to minimize stupid mistakes as much as possible, right? So this is something that you could easily screw up on when it's very easy once you write it out, okay? So are we good with that? Are we good so far, everybody? Please tell me if I'm going too fast. Perfect. Great. I'll leave that open. Okay. Your message from 6, right? Okay, so from here is missing emphasis. So you decide to add these 2 lines to your program. Think carefully about memory contents given how your string was allocated in 6 before answering. For int I 4 to 10, I++, you're adding exclamation marks. So basically, your message was help before, and now you want it to be help with a bunch of exclamation marks. Well, what would happen after this code runs? Does anybody see like a potential problem with how this looks? Does anybody have an idea? Don't worry if you're wrong. It's perfectly fine to be wrong. Any guess whatsoever? Anybody? Okay. I'll just go on and say it. But can somebody tell me what is stored? Let's forget this question. What is stored at p plus 4? Who can tell me what that is? Yes, exactly. -0. Exactly. So here they're starting at 4, which is good because that's where you should start. But now they're going from 4 all the way to 10. So it'll look like this. So 4, 5, 6, 7, 8, 9, and then it won't go to 10. So that's how it'll look. But they never add this end of line delimiter. So it'll just start printing like this, or like this and that and thing like that, like if you try to print it. So it doesn't work correctly and print out the string. It might not crash. The program prints help followed by junk. That is the correct answer. It's C. It will compile because the compiler can't tell that, oh no, this person's actually screwed up his string, and it compiles, but the compiler detects and prints an error when the code is running. That's also not true. That won't happen either. The program will print help followed by junk. So this is kind of going into the example I told you earlier. Which of the options below is something we cannot do with compound data types? Create an array with them. That's false. You can create an array of them. Pass them as parameters to functions. You can also do that through pointers. Therefore, you can pass them through as functions. Get a pointer to individual fields within the variables. You can also do that using the ampersand symbols. Create them on demand. You can do them using calloc. Use them in a for loop. I think this is like really poorly worded, but I think I understand what they mean. I think what they mean by use them in a for loop is like loop through the fields in a string, in like a structure, which you can't do. Let's say you have 3 fields. It's like name, age, and profession. It's not like you could like loop through those things and print them, right? You just can't do that. But this is a bit of a weird question. So if you ever got a question like this, I would definitely ask Brian or something for like clarification. Let me just drink some water, guys. Sorry, hold up. So next question. So which one is the answer? Oh yeah, good question. Good question. So according to the thing, it's C. Which was C. Use them in a for loop. So I think it's like they were referencing you can't loop over the fields in a struct. Yeah. So it's C. Okay. Suppose, okay, yeah, this is a good question. Suppose that you're given the task of implementing a little database for an online book/music store called Aquamarine. The store provides interactive touchscreens where customers can search for books or music they want using keywords. There is a master linked list that contains all the information regarding every book and musical album the store sells, and it is a requirement that the list is kept in sorted order by the title of the book or album. Which of the functions need to be carefully implemented in order to implement this functionality? So it's key that, so it says that it's required to be kept in order. So list traversal That doesn't need to be carefully implemented. You just use the .next pointer. It's the same thing for every type of linked list ever. Delete. That's also the same. You loop through it. Once you find the ones, you just take out that pointer and then reconnect the list, right? So if you delete a pointer in the middle, you're almost left with like two broken linked lists, right? So you need to connect them back. So that's all it is. That's also standard in every single linked list. strcomp. I don't even know what that means, but that doesn't make sense at all. To compare strings, that's a given library. That doesn't need to be carefully implemented. So that doesn't make sense. Search. That also doesn't need to be carefully implemented because you just, iterate over the linked list and to search for keywords or whatever. Insert. When you insert something into the linked list, you need to make sure you're going to the right you're putting it at the right place. This needs to be very carefully put because this kind of affects how everything is done in the store, whether it be searching, deleting, things like that. It's required that the list needs to be kept in order. So you need to be able to insert it incorrectly. So that's insert. In the diagram above, what is the value of p? What is the value of p after p equals at arrays at index 0 plus 2? So the address of array 0 is here. So 3241. We're not looking at the value because look at the ampersand symbol. It's the address. So 3241 plus 2, 3243. That's the answer. Simple as that. Suppose p at array 0 is equal to p is equal to the array address at index 0. What are the correct instructions to swap the second and fourth entries in the array? So whenever you see something like this, a two-liner, that never works when swapping like things in an array. You need something buffered to keep in the middle. So what I mean by that is p plus 1, so 22 is, so now I'm going to bring -5 and assign it here. Then I'm saying, okay, now here, take what's here and assign it here. But we put -5 here. So then I'm just putting -5 back here. So it's -5, -5, and this 22 is lost forever. So that's not right. I equals p plus 1, so 3242. P plus 1 is equal to p plus 3, so 3242 is equal to 3. Yeah, like now you're just like mixing up the memory addresses. That's not correct either. That makes no sense whatsoever. Let's go over the correct solution just because I don't want to go over these two. I is equal to the value at p plus 3, so -5. The value at p plus 3 is now going to be equal to the value at p plus 1, which is 22. So now 22 is here. But we still have that -5 since we stored it in I. Then p plus 1 is equal to I. So now the 22 is getting replaced with -5 because the 22 is moved over here. That's how you correctly do it. So very simple. Just read through every single solution and determine if they do it correctly. Because everything, like these other ones, are just so blatantly wrong, you should be able to figure it out. Suppose r is equal to the pointer at rev, and p is equal to the pointer to the array at the first index. What instructions update the score field in the review variable to 5? Okay, so let's see. So A, we're given the value of r dash point to score is equal to p plus add p plus 2, so add p is 15 plus 2, which is 17, so that's not right. R dash score is equal to pointer at p plus 2, so p plus 2 is 5, so we're good there. And then r dash score, this is the correct way to use a pointer to reference a field inside the structure, is equal to p plus 2. That's perfect. What's wrong with this? R dot score. We have a pointer, not the actual structure itself. So this is wrong. This wouldn't work. Rev dash score. Rev isn't the rev is a point. We don't have necessarily rev. And then rev is an object actually. So rev arrow score, that's not correct either. And then rev also, again, rev arrow score, that's not correct either because that wouldn't work since rev isn't a structure, not a pointer. So yeah, it's obviously this one, very simple. P is equal to at the pointer address to I. What is the value of R at index 1 when we run the following code? So for open bracket at P is equal to 0. P is equal to less than 4 at P plus plus plus. R at dash P. Okay, so this looks a little tricky, but we can go over it. So what I'm kind of confused about is where is, sorry, I is up here somewhere. Yeah, okay. So, okay, so it's equal to nothing, but we initialize it as 0. Then we do dollar at P plus plus. So keep in mind, we're actually incrementing this value itself, what's inside P. We're not incrementing, what's inside I. We're not actually incrementing the address itself because look at this notation. We use the star, open bracket P, close bracket. So that's how we know we're referencing the value. So R at bracket P is equal to open bracket P. So R0 is equal to 0. R1 is equal to 1 because we're just incrementing it. It's a simple for loop. It looks complicated, but it actually isn't. We're just, whatever the index is, we're just giving that to the array itself. So it's just equal to 1. There's nothing wrong with the code. You're not going to get junk. You're not getting these random values because we're concerned about the value of the pointer, the value the pointer points towards, not the pointer address. So we're not going to get these like weird addresses. We'll just simply get 1. Now, 15. This is actually one that this person got wrong. The correct answer was C. They answered B. So let's try to figure this out. So basically, which of the following do you think is like a bug? P is equal to pointer to I. R is equal to pointer to rev. So the correct answer is C. And I'll just so P is equal, all of these 3 ones, I'll kind of try to skip that just because it's so obvious that they're correct because they're not doing anything illegal. The only ones that are weird are B and C. So let's look at B, right? So P is equal to like at I, right? Now I'm saying P is equal to integer cast for a pointer of the pointer at rev. So what is this statement doing? It's taking the pointer to rev, the pointer address to it, and integer point casting it almost. Like, because you know how you can typecast with an int? You can also typecast to an integer pointer and assigning that to P. Don't get me wrong. This value will be complete garbage because rev is actually, sorry, I think I missed it. Rev is of type review. So it's a completely different structure. So it'll be pure garbage, right? But you can do it. You will get pure garbage out of it, but it will work. So, right? It won't cause a bug. It won't cause a crash. This one is wrong. R is equal to at rev. Value at R plus 1 is equal to value of R. So let's go look at R plus 1. So R plus 1 is integer. We're trying to take this and put it into here. These two aren't compatible. You can't put a type integer into a type review just like that, right? You at least need some sort of a typecast, which they don't even try to do. So you'll definitely get an error. So that's the bug. But I wouldn't blame you if you tried B too, but it's definitely 100% C because you're trying to put one variable type into another variable type without an explicit typecast. So that kind of ends today's review. What I'm going to ask right now, does anybody have any questions they have? Anybody at all? Okay. No problem, Zexy. Thank you for coming. Do you think I could share this copy of the midterm? I don't think I can just because it belongs to someone, and I don't think Brian would be too happy with me doing it. Me doing that. Okay. Philong, I'll get to your question, but no, I don't think I could, go over this copy of the midterm, like share it publicly, just because I think that is against the rules, and I don't want to, like I kind of already have given it to you by going over this, but sorry about that, Olivia. Hope you understand. Okay, so the last Pokemon question. Okay. 10.1. So this one right here. The oh, so just returning a okay, cool. So these two are kind of the same questions. So I'll try to go over this better. Yeah, I didn't explain this great. So basically, do you understand the question itself? I'll ask that first. Okay. So what do we need to do? We need to return a list. Why we need Calig? Okay, good question. So do you understand we're looping through the linked list the first time just to count how many creatures are hungry, right? So let me ask you this. Let's say I have 5 creatures that are hungry and 3 of them are hungry. How would you give, let's say Brian asks, oh, I want the 3 Pokemons that are hungry so I can feed them. How would you return them? Give Brian those 3 pointers. You have 3 separate values. So you can't just return one of them. You can't return you need to return all 3 together, right? So how would you do that? A new pointer node to access those addresses. Yes, but you need multiple pointers, right? You can't just use one, right? If you have 3 Pokemons that are hungry, you need those 3 pointers to those nodes, correct? You kind of follow me so far? Right. So you have those 3 pointers. You need a way to return those 3 pointers. So what's the best way you can return those 3 pointers in like one collected, object almost? In an array, right? Are you with me so far? So we have 3 pointers. You're with me there, right? The 3 pointers, we need to return 3 pointers, right? Are you with me there? Okay. So I'll just give you an example. So let's say we have those 3 pointers, right? And we know what they are, but they're weird numbers. 10,024, then it's like 50, it's like 10 actually no, we'll use simpler. It's like 10, 23 and 46, right? Those are our 3 pointers, right? We can't just do return 10 or something like that. That's wrong, because what about the other 2 pointers, right? So what we have to do after that is we need to somewhat actually kind of declare uh, a a pointer array. So what I mean by that, it would look like something like this. Sorry if I'm not getting the exact syntax correct. It's been a while. My hungry Pokemon. So we're declaring it with size 3, right? But you can't just do this. You can't do that because sometimes the C programming language on your computer or on whatever device it's running on, it might not have that type of memory. So then after that, if you try to do something like this, where you're like, something like this, sorry. Sorry about that. Don't need that. This might not work because C didn't actually allocate this array because it had no memory. So we use calloc so we can actually tell C, hey, I need to allocate for this size array. You know what I mean? So you would write something like this, and then you also need to do like 3, then size of Pokemon, something like that. So do you kind of get why we're using calloc here? Because we need to tell C, hey, you need to allocate for this type of, this size of an array before I use it. Yeah. Okay, cool. So that's the second question is kind of like this is your linked list and then this is your array. So 41, 42, 43, 44 is like your array of size 4 and then 2, 5, 11, 9 are referencing the addresses of those like, nodes. Are you good for the second question too? Phelong, are you good with the same? The second, oh, so it's just asking you to draw a diagram to illustrate how the list returned by your function works. So how to, it's almost like you just illustrating your solution. So you're saying, oh, this is the linked list. You can be of any size, and then here's the array. We declare the size, and then we put all the pointers in it, and then we return it. It's just like drawing it out. Are we good there? Okay, perfect. So does anybody else have any other questions? Anybody else? Okay, so would anybody like me to have like another review seminar tomorrow? So I can go over more questions. You would, okay, so Zilong would like one? Okay, cool. So I won't probably have any material planned, but I'll just have like another Zoom meeting where you guys can uh yeah, pop by. Yeah, sure. So I'll try to like get this posted today. I don't know how long that'll take considering this was it's like 9:18, so it's been like roughly an hour and 15 minutes, so it might take a bit of time to upload, but so I'll try to have another one tomorrow. I'll get Brian to post it might be the same credentials as today, to be honest. But if not, I'll get Brian to post something on Piazza. So if does anybody else have any other questions? Feel free to ask. There's no harm. Okay, doesn't look like anybody has any questions. So I guess that's all for today. I will make sure I can post this by today, hopefully, or probably tomorrow by noon. And Brian will also make another Piazza post telling you guys about. So Brian will also make a post like showing you where the link is to this video, and then he might make another post or onto the same post what the new meeting details are. So is everybody good? Is everybody happy? Everybody hopefully a little bit more prepared? Everybody good? Perfect. Happy to help, guys. So I guess I'm gonna end the meeting for today, and then I'll try to get these recordings to you guys as soon as possible. I actually have one more thing. Here is here's my email. If you guys have any questions, feel free to like email me in between if you don't want to wait till tomorrow night, since I know the midterm's coming up quick. But yeah, there's my email. So if any of you need answers, or you can ask Brian for my email. Other than that, thank you everybody for attending today. I'll see some of you guys tomorrow. Good luck with your midterm. Yep, no problem, guys. My pleasure. Bye, guys.